Homework 42, as you could see, it's the exact same sections as we did in homework 40. Homework 40. The problems are different. There's only 10 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes, there's only 10 of them. And here, last time I told you to do all 4 steps, and I'd tell you what the steps are. I'm adding a 5th step, and otherwise, it's going to be exactly the same thing. Now, you might be wondering, hey, wait, didn't we already do this? And I just want you to use your reasoning here. If your teacher's having you do exactly the same, and note, I have not graded these homeworks. I have not seen your homework 40 yet, so it's not like you guys messed this up so severely that you need to go back and do it again. It's not that at all. If your teacher is telling you to do something again, instead of moving on and covering new material, then this must be very, very important, right? Like we could reason from that. And indeed it is. This is more what we're doing here, right? Which is, notice, we're doing stuff that we're talking about in, what we will be talking about in chapter 12. That is parabolas or quadratic equations, right? Which are second degree polynomials, or second order, no, so we call it degree, second degree polynomials. And, but we're doing it here, right, and I'm giving you this weird thing that's different. What I'm trying to do here is connect a bunch of concepts that normally they don't all come together until much later. And by coming up with this exercise, the way I want you to do this, I'm hoping that we could go ahead and solidify a few concepts right now. That way you'll have them for the rest of your mathematical career. So what I'm going to do, believe it or not, I'm also going to start exactly the same way with the same proof that we did last time. We're going to talk about how we could factor down some polynomial. We have some quadratic polynomial. Ax squared plus b. This black looks terrible. Give me a second. I got to do something. This just looks horrible. Okay, and that's funny because that's a brand new marker too. That's annoying. Okay, we have some a which is non-zero. That's key here, because if it were 0, right, then this wouldn't be a quadratic equation, or it wouldn't be a quadratic polynomial. It would just be a line, right? Yeah. Right, bx plus c, that's the same as mx plus b, right? So a has to be non-zero for any of this to matter. And what we did is, remember, we want to find the roots of this, which is the same thing as factoring this thing. Because once you factor something completely, its roots are right there for everybody to see. Similarly, and this is as we did before, if you know the roots, you could reconstruct the polynomial if you know the roots and you know the leading coefficient, a, right here. And so, okay, what we did last time, factored the a out of the whole thing, and that gave us x squared plus b over a, x plus c over a. And now you could see why it's important that a is non-zero, because I would have just written something divided by 0 here. That doesn't make any sense. And so from there we say, okay, what we want now is, can we factor this remaining polynomial here? We have a times a bunch of junk. Can we rewrite this? Can we factor it down? So we have a minus 1 root, x minus 1 root, x minus the second root. And what we could do, if we were so inclined, we said, well, okay, hold on. This means, since a is a, this means the same thing as plain old x squared plus b over a x plus c over a is equal to this part, the x minus r1 times x minus r2. And if you wanted, you could multiply all that out and you'd get a bunch of stuff in terms of r1 and r2, and you could relate them to each of these coefficients, and it doesn't really help you that much. But there's this magic step you could take where you say, well, suppose that the roots have this form. Suppose that the first root, why am I calling it? It doesn't matter which one you choose, but one of them, pick one of them and call it number 1. And let's say that it could be written as some d plus e, where d and e are some real numbers. Suppose that root 2 can be written as d minus e, the same d and same e, but one's plus and one's minus. And and like I said before, you never would have thought this, you never would have guessed this, right? This is just an assumption we're going to make, and we're going to see if it helps us out. And so I'm just going to plug this in here and say, okay, if R1, I have X minus, instead of R1, now I'm going to use parentheses, because I have a minus there, right? Like, if I minus this, they both got to be negative. You can't just put the minus in front of the D, so I'm using parentheses to be very careful, etc., blah, 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 blah. And again, we've already done this, so I'm just going to burn through this now. Okay, I've replaced the R1 with D plus E, replaced the R2 with D minus E, and let's just see what happens. First, outer, inner, last, we get X squared. Outer gives me minus D minus EX. Inner gives me minus D minus EX. Last gives me a negative times a negative is a positive, so that's plus D plus E times D minus E. And then I'm going to go through and distribute these guys out. I'm going to say, okay, X squared. The minus D plus E, the X comes in, and I get a minus DX plus EX when I distribute him. I distribute the minus in, I get a minus D plus E. Oh, you see, look at this. Look at what I did. This should have been a plus right there. Right there. That should have been a plus. See what I did? I messed that up. You should have caught that. Everybody gets like 9 points off today because you didn't catch that. Okay. Anyway, that should have been a plus, and so you distribute the negative in. It should be D minus E. Distribute the X in. Minus DX minus EX. Now I'm going to distribute the minus in. I get a minus D. Bring the X in. The X comes along. Minus minus is plus E. Bring the X in. You get an X. Now this is nice. First, outer, inner, last gives you first is D squared. Outer, inner cancel because you get a minus DE plus DE, which works out to a big fat 0. And that's kind of why this thing works, is that you're using, they call these conjugates of each other. D plus E, D minus E. When you do this kind of manipulation, these things end up canceling out. And then you get your plus E minus E is a minus E squared. It's all stuff we've done before. Now the cool thing here, another cool thing about the plus minus thing, is now we have a plus EX and a minus EX, and that stuff goes away. And so we could reduce this down to X squared. You have a minus DX minus another DX, that's minus 2 DXs, so minus 2D, whatever D happens to be, times X. So that's that guy and that guy. And then plus, and I'm going to put this in parentheses, whatever D squared minus E squared is. Doesn't need to be in parentheses, but now we could see, and the reason I'm doing this in parentheses, I want to do this one in parentheses too. That's a minus, we write that as a plus minus stuff. Is that if these two things are indeed the same, then minus 2D has to be the same thing as B over A. So B over A, that coefficient, has to equal negative 2D. Put this in parentheses to show that if this thing is equal to that thing, then C over A has to be equal to D squared minus E squared. Now you have two equations, two unknowns, and like we talked about before, you might say, well, A, B, and C are unknowns. Well, no, they're not, because we're assuming that you started off with some polynomial, whatever it was, like 5x squared minus 3x plus 7. So you know what A, B, and C are. The only unknowns now are D and E. Because again, that was the whole point. We need to factor this thing. I need to find R1 and R2. Can't do that so easy, so let's write R1 and R2 in a way that helps us out. And clearly this helps us out because it reduced a bunch of stuff. Now, we could say we have two unknowns, two equations. I could get one of these things by itself pretty easily. If I divide both sides by negative 2D, so 1 over negative 2D, 1 over negative 2D, multiply both sides by that. The negative 2D's cancel over here. I get D equals, and I'm going to put the negative on top, negative B, I shouldn't have divided by 2D, what am I doing? But negative 2. Sorry about that. That should have been a negative 2. You don't want the d to disappear. That would be bad. So negative 2a is what comes down there. Then we just like we've done before, this equation is not linear, but we could still use the same property, the same methods that we used before when we were dealing with linear equations and saying, well, hold up. If that's the case, I could plug this guy in, and I get c over a is equal to whatever this thing is squared minus e squared.
Wait, you're just going to get the r equals equation from last 2 classes.
Exactly. Precisely. That's exactly what I'm doing. Like I said, I'm going over this again because this is so important. And who knows, this very thing that I'm doing right now might show up in a extra credit problem that you might see at some point in the future. And maybe you want to be able to do this and like derive this from first principles. Maybe. I don't know. I don't write the tests. Oh wait, yeah, I do. Okay. Now, let's go ahead and multiply this out. This is that thing squared. It's that thing times itself. So negative b times negative b is b squared. 2a times 2a is 4a squared. And then minus e squared. We have d by itself, so that's nice. We could put that in terms of a and b. Now, all I need to do is get that e by itself. So I'm going to add e squared over here. So I'm going to do this like this. I'm going to take him over here and take him over here. Can I do that? Can I just do that in one fell swoop?
Yeah.
So that I get e squared shows up on the left-hand side. That's equal to b squared over 4a squared. Now, the c over a comes over, I subtract him off, and that's what I end up with. The only problem is, I would like to simplify this a little bit more before I take a square root, and so I want to get a common denominator. I'm missing a 4 and an a in the denominator here, so multiplying the bottom by 4a and multiplying the top by 4a gives me e squared is equal to that common denominator, 4a squared. The top over here is just b squared, minus, now I could write it as c4a, but I like to keep them in alphabetical order and put my constants out front, so that's 4ac. Right there. We take the square root of both sides. Actually, we're not ready to take square roots yet, because it's a subtle thing that we're going to deal with in Algebra 2. But we could just say, if you took something and you squared it and you got this, what must have that thing been? Well, it must have been the square root of the top, which is b squared minus 4ac, and the bottom would be the square root of that. And I'm telling you, the square root of 4a squared is 2a, because if you take 2a and multiply it by itself, you get 4a squared. So this must have been 2a down here. Everybody got that? And we've already done this, right? We've already done this. So there's nothing new here. It's just, now it's on video, and maybe you want to learn how to do it, because you might see it in the future. It might be good for you to be able to work this out. Anyway, and so now we say, okay, then the two roots that we're looking for, I'm going to go ahead and erase this right here. Erase some of this work and say, okay then. The two roots that we're looking for, root 1 is d plus e, so we have minus b over 2a, which was d, and then we plus this bit, which is the square root of b squared minus 4ac all over, nice, 2a. We could write that with one common denominator. I suggest that you don't. The other one is d minus that amount. D was minus b over 2a minus the square root of b squared minus 4ac all over 2a. And if you see it in the literature, in your book, every book I've ever seen writes it like this: negative b plus or minus the square root of b squared minus 4ac all over 2a. And as you can see, that's all that is. And that plus minus is doing a little bit of work. It's just saying like, okay, yeah, I understand that there's actually two roots because I remember where we came from. That was the point of this, right? I'm looking for two numbers that factor this thing down. One of them you get by going plus, one you get by going minus, and so we're just going to write it as plus minus. But we understand that this really means two different things. Everybody got that?
Yeah.
This is just review. We've done this before. Okay. Now, and I just want to stress that this way will be very useful for us. Instead of writing it all with one common denominator, which you can, it's perfectly fine to do it. It'll work out. But in the near future, it'll be nice to think about it this way. You'll see. So, anyway, there we go. That's just review. And since I knew I was going to be videotaping this, videotape, you guys probably never would ever say that. Since we're putting this online, and it will be there forever, or until YouTube fails, then it's nice to have that down. I want that, you could reference that for the rest of your lives. Like I said, there is another more direct way without that crazy assumption like, oh, well, R must be D plus E, D minus E. Like, nobody would have thought that. There's a more direct way of getting to the same thing. So, anyway, I'm going to go ahead and just keep this up here, what we just had, is that the roots are given by minus b over 2a plus or minus the square root of b squared minus 4 times a times c all over 2a, like that. And that's going to be our formula. That is called the quadratic formula. The roots of a quadratic polynomial are that. So, I want to do one thing before we actually get into examples from this part right here. And I'm going to start by doing this. Let's start with this polynomial. First off, we know what the roots are because it's written like that. And remember that the roots are the values of x which turn it into 0. Remember, right? That's what that means, right? So that when you plug in an x, like you get out a 0. That's the special x we're looking for. And what are the roots here?
-1.
It's -1 and?
-1.
And -1. It's the same one. We call that a repeated root. And it may seem like a subtle thing, like why do you write the same thing twice? Well, you could write it once and that's fine. It's just that, watch what happens. Let's go ahead and multiply this out. You guys tell me, let's multiply it out and pretend that we've never factored this thing before. What do we get? First outer and last?
X squared.
X squared.
Plus x.
Plus x.
Plus x.
Plus x.
Plus 1.
Plus 1. So let's simplify that down a little bit and get it into the form ax squared plus bx plus c. What do we get?
Plus 2x.
2x. And then plus 1. Now, the a here is what number?
1.
1, right. We didn't write it, but it's there, right? And b is what?
2.
2. Not -2, positive 2. And c is what?
1.
I want you to see what happens when we plug this into this equation. So again, pretend that we had not factored this thing out and that you don't immediately recognize it as the square of a polynomial. I mean, as the square of a monomial, because that's what this was. I just did this, right? That's what that is, and it has that form. But we're going to pretend that we never saw that, and let's just plug them in and see what happens. So I'm about to plug this into, I want to find the roots. So I'm going to write this down first, plus or minus the square root of b squared minus 4ac, and then over 2a. Now what I'm going to do, I suggest you do this, right? This one's pretty simple, but when there's pluses and minuses all over here, it can be really tough. So what I'm going to do is everywhere that I have an a, a b, or a c, I'm going to replace this with parentheses. And it's going to look like this. And then I'm going to go through and make sure I'm doing this right. So the b should be 2. So I'm going to put a 2 right here. That's over a, which is 1, so I'm going to plug in my 1 right there. Here's my b squared. I'm going to find my b is 2, plug them in. Here is an a is 1, I'm going to plug him in. Here's a c is 1, I plug him in. Finally, a on the bottom is a 1. Nice. Okay, so now let's figure this out. Can I simplify this? What does this work out to be?
-1.
Just -1, right? Because the 2 and the 2 cancel. You have negative 1 over 1 is just negative 1. All right, now let's write this down. 2 squared is what?
4.
4. Minus 4 times 1 is, what's this quantity?
4.
4, okay. Now what about in the denominator? What's 2 times 1?
2.
Okay, so my solutions are, what is 4 minus 4?
0.
Okay, and what's the square root of 0?
0.
It is 0. 0 divided by 2. What's 0 divided by 2?
0.
It's still 0. So we have negative 1 plus or minus 0. What's negative 1 plus 0?
Negative 1.
Negative 1. And what's negative 1 minus 0?
Negative 1.
Aha. So that's this might happen to you as you're doing some of these, and you go, wait a minute, I'm supposed to have 2 roots. Well, this is what this means. That's all that means, is that you have a repeated root. And it's interesting, it shows up twice, right? Because you go plus and minus 0, you get the same thing. Yeah, but you do have 2 roots, right? Like, this thing is not simply x plus 1 just by itself, right? There's 2 of them. And so that's what this is telling you, is that it's not enough to just find one of them and say, okay, you have 1 root, and so therefore that's what your polynomial looks like. Well, no, there are 2 of them. Yes, they happen to be the same, which means that that factor is the same. That factor is repeated. Okay? Everybody get that?
Yeah.
Okay, so that's going to pop up a few times, I'm sure, definitely in your life, that's going to happen. And that's what happens. And this thing right here, this quantity, b squared minus 4 times a times c, this is called the discriminant. Oh, I think I could write that down. Discrim. And it's innate, discriminate. Or discriminant. I don't know. It's one of the two. I think it's discriminant. Discriminant. Yeah, not discriminate. But you can see where it comes from. Discriminate. How can you discriminate between different things? If it's 0, then you have repeated roots. Right? Because if this is 0, this whole thing becomes 0, right?
Yeah.
Right? If what's in there is 0, then the square root of 0 is 0. 0 divided by anything is 0. And so you end up with plus 0 minus 0, and so you end up with repeated roots. If it's positive, then you have 2, then this is not 0, and you have some number here. You're taking whatever this works out to be, maybe it's negative 1 like it was, and you're adding something and you're subtracting something, you'll get 2 distinct roots. If it's negative, wait for algebra 2, and we'll talk about that, because something interesting happens. But using this quantity, b squared minus 4ac, you can discriminate as to what sort of polynomial this is. And so, it's interesting. It's an important quantity. Okay. All right, so let's do a bunch of examples. And again, you're going to just do this. And now I told you 5 steps. So the first 4 are exactly the same. We're going to factor completely. And remember what that means. We're pulling everything out so that you have nothing but, so that you're, well, we'll do it in a second. Okay. We are going to use the quadratic formula, QF, which is this guy, right there. Use the quadratic formula to find roots. 3. We're going to use the roots and the leading coefficient, right? That's your A. The leading coefficient to write the factored form. Four, multiply that out. Multiply this, that is the factored form that you just wrote in part 3. You multiply that out to check that it's the same thing that you got in step 1. Then finally, I'm adding a new thing here. 5. Plug in the roots to the original. The original polynomial. Not the polynomial that you got after factoring it, because that's just trivial. I want you to plug them into the original to check. And if you plug a root into something, what should its output be?
0.
It should be 0. Exactly. That's what we're checking. And this is what I'm trying to reinforce in your brain, is that the roots are the numbers which make this thing equal to 0. And really, I want you guys to believe that this is true, that this does work. And after you do it here 10 times, you probably believe, like, yeah, this really does work. So from section 6.5, problem number 2, it says, it gives you 3x squared minus x minus 4. So the first thing we're going to do is factor it completely. Okay, so step 1, factor completely. All right, so this has the form what must my first things be here?
3x times x.
Yeah, because we're factoring this, like we could go root 3x, but we're not trying to do that. We don't want to go that route. That's a tricky route to go down. So we're going to say, okay, 3 is 3 times 1. So it must be a 3 and a 1. Okay, now
And then there's a 4 in the one with the 3, and there's a 1 in the other one.
So which one has the 4?
The 3.
The one with the 3 has the 4. I agree. I'm going to try a 4 and a 1 because the 4 times 1 has to give you the negative 4. That also means, since there's a negative there, 1 must be positive, 1 must be negative.
The one with the 4 and the 3 needs the negative.
The one with this one needs a negative. Let's check it. Minus, plus. First, outer, inner, last gives you 3x squared. Yes. Outer is plus 3x. Inner is minus 4x. Great job. That gives you your minus x, which is what you have. Last gives you negative 4. Positive 1 is a negative 4. We're good to go. We have factored it. But have we factored it completely?
No.
Yeah, remember, I'm going to make you do this weird step where if there's something in front of the x, factor him out. And so I'm going to pull the 3 out there. I notice there's nothing to pull out here, so I'm just going to copy him down. What is left over after I factor out the 3?
X minus 4 thirds.
X minus 4 thirds. Now, if there had been one to pull out here, I would bring him over, absorb them all together, and then check, absorb them together. What I mean by that is, like, if you had a 2 and a 5 like this after factoring, that you bring them both together and write it as 10, right?
Oh, yeah.
That's what I mean. Like, you bring them all together, and now you could just kind of check and say, is that number the same as A? Yeah, okay, then you're on the right track. If you get to this point and that's not the same number right there, it's something went wrong. That's not good. It has to be that way, right? Because when you multiply this out, first, outer, inner, last, that gives you an x squared. And if that's a 3x squared, there's only one number that's going to make that work. Right? Yeah, so okay. So that means now we could find, if we, that's not part of this, but this tells you that the roots are what? Let's just do as an aside. Roots are what? What's root 1?
Positive 4 thirds.
Aha, good. Positive 4 thirds. And what's root 2?
Negative 1.
Negative 1. There you go. Okay, now, again, you don't need to do this, but that's cool. Okay, so 2, we have factored completely, so we're moving on to 2, which is use a quadratic formula to find the roots. And really what we're doing today, this step is why we're doing, is one of the main reasons why we're doing this again today, because there's the mechanics of doing this, right? Like when you first start doing this, I guarantee you're gonna mess up 4AC like 5 times and you're gonna get the wrong thing. And that's why I want to give you a way of doing this that's gonna help you every single time you do this. And the more practice you get with this, the better. So this is what I do. I suggest you start by actually writing down the formula, though And this is another thing about this. Actually writing down the formula will help it go deeper into your mind. And this is one of the few formulas that I suggest you remember for the rest of your life. You should be able to wake up from a dead sleep and somebody says, what's the quadratic formula? You go negative b plus or minus square root of b squared plus 4ac over 2a. You should be able to do that right there. Okay, but anyway. So actually copying it down will help you. Now use parentheses like this. Everywhere that there's an A or a B or a C, you just put parentheses like this. This step really helps with that 4AC in the radical here. Because the negative numbers are going to mess you. If there's negatives, it can mess you up every time. Okay, now we haven't explicitly identified this. So let's do that. What is A for this polynomial?
3.
3. What is B for this polynomial?
Well, negative 1.
Negative 1. Uh-oh. And what's C?
Negative 4.
Negative 4. And that's why this step is so important, I think. And I'm telling you, I do this every time. I don't always write this down because I've already written this part down 1,000 times. But every single time I use this formula, I usually start by writing it just like this. Otherwise, I'm gonna mess up a sign. I know I'm gonna do it. So here we go. The B right here is negative 1. So I'm gonna put the negative 1 in there. That's over 2a. A right here is 3. B is negative 1, so I put a negative 1 in there. AC, A is positive 3. C is negative 4. Okay. A down here is a 3. Now, I'm going to go ahead and see if there's some simplifying things I could do here. A negative negative is a positive. So I'm going to forget about it. I'm just going to write that as 1 over 2 times 3 is 6. Just like that. Now I have my plus or minus. Okay. Now,
You should get 7 over 6.
let's see. Hold up. I will get there, hopefully. Now, negative 1 squared is positive 1. Now, this is one of the things. I notice that I'm subtracting a, and this is how I like to look at this. I say, okay, positive, positive, negative. So that whole thing, 4 times 3 times negative 4 is a negative number, right? When I do this, I should get a negative number. And a minus a negative. So I usually write it like this, and as I'm copying it down, I put a negative. Then I ask myself, what sign should that thing have? Well, in this case, I'm minusing a negative, so that's the same thing as plus a positive. Now I go through and put the plus right there. Then I forget about signs altogether, and I figure out what that is. 4 times 3 is 12.
It's 48.
Times 4 is 48. Good. So that's just 48. Now what's 1 plus 48?
49.
Okay, so I have a 6th plus or minus root 49 over 6, and you are absolutely right. That should work out to a 7, so 7/6 right there. 1/6 plus 7/6, so now I'm getting 2 answers, right? One of my roots is what I get when I add them. That's 1 plus 7 is 8/6. Okay?
4/4.
Which is what?
4/3.
4/3. That's nice. That's what we should get. Okay, good. And then the other one is what I get when I subtract them. 1 minus 7 is negative 6. So negative 6/6, which is negative 1, which is what we expect, right?
Yep.
Okay. So to save some space, I'm going to erase all of this work, but I'm going to pretend that I got these right here from this right here. It's just because now we're going through like you're going to be doing in your homework, okay? So you did all this work and now you got these guys and you wrote them down right here. Everybody got that?
Yes, question. What
Yes.
is the point of doing that if we already know what the roots are?
Okay. Again. Okay. Okay. This is good. Whenever you see one like this, whenever you're trying to find the roots of a polynomial, the first thing you try is factor it. And if it factors, then you're done. Because you could just look at that. Look how easy that was.
Yeah.
Boom, you're done. So you're going to do this whenever you can. But then you're going to have ones like this. And go ahead and factor that. And you're going to go, I can't. So then you move on to this. You understand?
Yeah.
And what I'm trying to do with this exercise is show you that it is the same. That what you're doing when you use this formula is you are factoring something that up until now you thought, like if I would have said, hey, go factor this, you'd say it can't be factored. I'm telling you, it can be factored. It absolutely can be factored because this thing works out and you will be able to factor it. And so turns out every one of these does factor. It's just there's an easy way of factoring it, which is like this. When it happens to work out nice, 9 times out of 10 it won't work out nice. And so then you need to factor it and you're like, how do I factor it? Well, here, like this. And so this whole point right here, 2 through 4, is to show you, is to really impress upon you, to get you to believe that it is the same. So you're doing it the easy way, yes, which is the way you would do it if you just encountered this thing in the wild. Like, if somebody just said, hey, factor this, you'd go, okay, ta-da, and you'd be done. But what I'm doing is having you do all of this so that you know that, yes, it does factor, even when you can't, even when you encounter one that you can't do simply like this, you absolutely can factor. It's just ugly. It's really ugly. So, and that's what parts 3 and 4 are all about. Because now you've done it a different way, which took you longer and was a huge pain. But now let's just make sure that they're the same. So we're going to use the roots and the leading coefficient to write this thing in its factored form. And so that is a times x minus r1 times x minus r2. And so we just, a was what?
3.
3. So I'm going to replace this with a 3x minus x minus. R1 is what?
4 thirds.
4 thirds. And R2 is what?
-1.
Now, I could write that as -1.
Or just a plus 1.
Or and that's what you do, right? Minus and negative is the same thing as plus or positive. So you do that. And then you look and you go, yep, it's the same thing. And now you pretend that you never knew this in the first place. You pretend that you never saw that. And you say, okay, if somebody just gave me that and they asked me, is that thing the same thing as that thing? We know it is because you factored it, I know. But we're going to pretend that you've never factored it before. So you move on to step 4, which is multiply this thing out. And that's what we're going to do. I'm going to first outer inner last this guy. First gives me x squared. Outer gives me 1x, so plus x. Inner gives me minus 4 thirds x. And last gives me negative 4 thirds. Let's combine these. That's 4 fourths that's 3 thirds minus 4 thirds, right? 3 thirds x minus 4 thirds x. That's what that is?
No, 4 thirds minus 4 thirds.
It's not 4 thirds. X.
What you wrote.
I wrote 3 thirds minus 4 thirds.
No, above. No, in that equation. 4 thirds x minus 4 thirds. Oh.
Yeah, I'm not talking about this guy. Yeah, okay. I'm trying to combine these x's, and what I'm doing here is this. I get lazy and I don't bother with the x, because I'm just thinking of the coefficient. You have 1 minus 4 thirds, which is 3 thirds minus 4 thirds, which should be minus 1 third, right?
Mm-hmm.
Minus 1 third x. So that's what I'm going to write down there. 3 times x squared minus a third x minus 4 thirds. When I multiply that 3 through there, I get 3x squared. The 3 kills the 3 and I'm left with a minus x. 3 kills the 3 and I'm left with a minus 4. Is that what I started off with? Was that my beginning guy?
Yes.
Okay. So the whole point about this exercise, we'll talk about 5 in just a second. The whole point about this part of the exercise is you really have to pretend. There's this question, It goes, how would you feel if you didn't eat breakfast this morning?
Hungry.
Right. And you imagine, well, if I didn't eat breakfast, I'd probably be hungry. I know me, I'd be cranky. I'd probably be a little angry, be quick to anger, right? Some people answer that with, but I did eat breakfast this morning. And it's like, right, but imagine if you didn't, right? It's the same kind of thing here. You look at this and you say, but I can factor it. It's like, yes, but imagine that you couldn't. Imagine that you couldn't, because you will encounter ones that you can't, right? And that's the whole idea of this exercise, is to say, okay, if I couldn't factor it, if I didn't know that it did this, what could I do? Well, I would do this and this and this, and that's what I would do. And then what I'm showing you here is, now prove to yourself that it is equivalent. Do you get the same thing? Yeah. Do this. Do you get the same thing? Yeah. And after doing this 10 times, hopefully you'll go, yeah, okay, it really is the same thing. You could go either way. And in some cases, please do the easy thing. But in other cases, you won't be able to. Like if I change that to a 5, good night. You could try all day to do this, or you could just plug it into here, and you'd get your answer. And so, that's the idea. And furthermore, now I want to impress one more thing upon you, is that now you plug the roots into the original equation to indeed say, like, yeah, if you plug them in, you will get a 0. And then you say, but look, dude, obviously, because that equals that, if you plug in the 4/3, you'll get a 0. And if you plug in a -1, you'll get a 0. And I'm like, yeah, I know, but pretend that you didn't know that. Pretend for a second that all you had was this. And you blindly, without thinking about it, plugged it into the quadratic equation and got those roots that you got when you blindly plugged it into the quadratic formula and blah, 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 blah. Now let's suppose that you did that, okay? Forget everything you've done now, and let's just see. Does that indeed give you a 0? Okay, well let's try root 1. So again, I'm about to plug something into something, so I'm going to use parentheses. They're your best friend. Now, I plug in my 4/3. I'm starting with 4/3. Oops, 4/3. Ugly. So that's 16/9 right there. 3 times 4/3 squared is 16/9. 4/3 is 4/3. 4 is 4. Okay. The 3 and the 9, we could cancel those out, and I get 16/3, yeah? Minus 4/3, minus 4. Right?
Yeah.
What's 16 minus 4?
12.
Okay, so I have 12/3 minus 4. What's 12/3?
4.
What's 4 minus 4?
0.
It does give you 0. Check. Nice. Now the other one's going to be a little bit easier. So you're going to do that. I want to see that.
You need to plug in both.
Yep. That's the idea. Now this one's nice because it's a -1. So 3 times, and please use parentheses, because notice that that one's minus x. It would be so easy to just, like mess this up. So parentheses are nice. They're your friend here. -1 squared is just 1, so that's just 3 times 1, right? Mm-hmm. Negative is a positive, right? So that's plus 1, right?
Yeah.
What does that work out to?
0.
Wow, nice, okay. And again, you're like, yeah, but we knew that. Yeah, I know, and I want you to believe, after doing this 10 times, that it's all the same thing. It's all exactly the same thing. The numbers which make this thing equal to 0 are indeed these numbers right here, which are the roots in its factored form, right? We call them the roots. That you could get those roots by either factoring it or by plugging those things into this formula. Which, by the way we got that formula was we factored the polynomial. That's the first thing we did, right? I wrote up a polynomial up here, and I factored it out and said, well, whatever R1 is going to have this property. Whatever R2 is going to have this property. And that's how I got that in the first place. I did it by literally factoring a polynomial. And so it is the same thing. It's just this just cuts to the chase. right? And when you can't factor 1 because it's difficult, because it has like a 7 in there, and there's no way you could multiply things to get 7 out of whatever, well, you still can't because we've done it in general now. Okay, same section, number 6. No, for time, I want to do one with another negative in it. Let's do this. 22. 22 is 6x squared minus 13x plus 6. It would be really nice if that were a 12. Because my first step would be, hey, 6, 12, 6, let's pull out a 6. We can't do that. So now, there's 2 possibilities. So we're doing part 1. We're just factoring it the way that we know and love how to factor it. And as a matter of fact, just for really, my whole point here is to work on this formula. So I want you to do this, the factoring part, but for time, I'm going to skip that part and jump straight to part 2. Is that okay with everybody?
Yeah.
Because, I mean, we've done these 1,000 times now, and you should be really comfortable with that. And you'll see, and this is another thing, Clara, to your point, like, but I can factor it. But yeah, I know, and that's how you should do it. When we come back, or the next time we do this, you're going to be doing ones that do not factor, like this one can be factored. And so you'll have to use this formula. Right now I'm just showing you that it's equivalent. So we're going to use a quadratic formula to find the roots. Negative b over 2a plus or minus the square root of b squared minus 4ac all over 2a. These are the roots. And that's a negative something over 2 times something plus or minus the square root of something squared minus 4 times something, all over 2 times something. Now, what's a?
6.
A is 6. What is b?
Negative.
Negative 13. Careful. And then c is?
Positive 6.
Positive 6. Okay, so this is how I deal with that. Start with the b here, plug in my b, and I have negative 13. Down in the denominator, I have a 6. b again, negative 13. A and c, I have 6 and 6. So 6 here, 6 here. They're both positive. Careful. Okay, and then in the denominator, 2a is 2 times 6. Okay. Over here in negative, negative, that's nice. That works out to 13 twelfths. Positive 13 twelfths. Because 2 times 6 is 12. Now let's take a look at, okay, so 13 squared should be 169. Good, okay, so 169. Now, I'm going to just, without thinking, I'm going to write a minus, and now I'm going to look up here and say, is that the right sign?
Yes.
Yeah, because we have positive 4 times positive 6 times positive 6. There's a minus there. Nothing's changing sign because there were no negatives over here. So I'm going to leave the minus there. Now, 6 times 6 is 36 times 4. 36 times 4. So I'm computing this right here. 4 times 6 times 6 is 36 times 4. 6 times 4 is 24. 3 times 4 is 12, 13, 14, 144. 144. 169, and then in the denominator we have 2 times 6 is 12. 169 minus 144 should be something 25. With a 5, 25. Okay. So we have 13 twelfths plus or minus root 25 twelfths, which is
25 or 5.
There you go, plus or minus 5 twelfths. So that gives me root 1 is what I get when I add them. That would be 18 twelfths. Yes. Is that right? Yeah, 5 and 13. Yeah, 5 and 3 is 8. So 18 twelfths.
It would be 9 sixths.
9 sixths. Does that come down some more? 9 sixths is the same thing as 3 times 3 over 3 times 2.
Thirds, 2.
So 3 halves, 3 tooths should be. Let's see, divide the top by 6, divide the bottom by 6. Yeah, okay. And then R2, 13 minus 5 is, what is that, 8?
8.
8. So 8/12. Half of that would be 4/6. Half of those would be 2/3. So 2/3. We didn't do the factoring thing, but if we were so inclined, we would go back and say, okay, therefore, this polynomial must have the form, the leading coefficient, which is 6, times x minus 3/2, x minus, again, 2/3. You'd multiply that out and check that, yeah, indeed, it does come out to that. Now let's do it. Let's check the roots, which is the new thing. Okay, so put it up here. R1 is 3/2, R2 is 2/3. And it does not matter which one you call R1 or R2. It does not matter. Because you could write this in any order. There's nothing special. I guess the way I derived it, I called d plus e root 1, and I called d minus e root 2. It doesn't matter. There's no standard thing about it. So, let's plug each of those into the original equation and see what happens. 6x squared, so 6 something squared minus 13 something plus 6. So I'm going to start by plugging in my 3/2. There's 3/2. Plug in my 3/2. There's 3/2. Now, 3/2 squared is 9/4. That's going to get multiplied by 6. Halves. 13 times 3 is 39. Plus 6. Now, the 4 in the denominator could be a 2, and so I would do 3. Yeah, does that make sense? I did 6 in the numerator, 4 in the denominator. I said that's the same thing as 3 times 2. The bottom is 2 times 2, and then I canceled the 2's. Leaves me a 3 in the numerator and a 2 in the denominator. So we have 3 times 9, which is 27 over 2, minus 39 over 2. That was fast and furious. Did you guys get that?
Yeah.
Okay, so plus 6. So 27 minus 39 is 12? Negative 12?
Yes.
Negative 12/2 plus 6.
Which is -6.
Hey, nice, and it should be. It really should, it should be. Like at this point, right? Like at this point, you get here and you go, well, yeah, obviously, like it really should work out. None of this should not work, right? And this is the whole point. You're reinforcing this so that by the time you get to the end of this homework, you go, yeah, okay, I get it. It's worked every single time. Not only have I seen the proof, and that's the thing about the proof, is it's like you have A's and B's and C's, and you go, yeah, okay, I see that, yeah, it would work. And what you could do is take these and plug them back into the original ax squared plus bx plus c. That's a great exercise, and you see that it does work out to 0. It's hard and it's ugly, and you have to do a lot of rearranging, but it does work out to 0. But this is nice because you get these that pop out of nowhere. You get 3/2 and 2/3, and then when you plug it into this original thing, you see, no, it really does work. And that helps build your intuition for everything, and it's a great exercise. So this is what we're going to do. So 2/3 squared, this gives us 6 times 4/9. 2 times 13 is 26/3, and hopefully this works out to be a thirds of some sort, because 6 is 2 times 3, and 9 is 3 times 3. And we have our 4 up here. And then 1 3 cancels with the 3. You have 2 times 4 left over, which gives you 8/3. Minus 26/3. Plus 6. What is 8 minus 26?
-18.
Negative 18. Okay, so that gives you negative 18/3. Negative 18/3 plus 6. What's 18/3?
6.
So it gives you negative, yeah, right, of course, it had better work out. Negative 6 plus 6 is indeed 0. Does this make sense? What I'm asking you to do?
Yeah.
Okay. again, you're like, we're doing the same thing. Okay, yeah, you added one extra step in there. But we're doing the exact same thing we did in homework 40. That's because this is important. And if you come to believe this concept and know it in your bones, it will make your life so much easier going forward. So I really want to take time to reinforce this.